Additional practice P5W2020. Let's do with the first question. This question, you're not allowed to use calculator. The length of a painting is 2 meters and its breadth is 1 5/8 meters. Find the area of the painting. Express your answer as a decimal. So this question is asking for area, and the formula to find area is length times breadth. So the question is very direct. 2 meters is the length, breadth is 1 5/8 meters. So it's simply 2 meters multiplied by 1 5/8 meters. So 2 times 1 5/8. So before you multiply all fractions, there's a few ways to do this. One is the whole number multiplied by the whole number, and the whole number multiplied by the numerator here. So I find this is the easier method. The other way to do it is convert the mixed number into an improper fraction, and then you multiply. I would say the first method is easier because you do not need to deal with huge number, especially when you are not allowed to use calculator. So step one is whole number multiplied by whole number, and you will get 2. Then the whole number multiplied by the numerator of this fraction, you get 10/8. Now you can simplify by converting this improper fraction into a mixed number. So this is you get 1 more whole, become 3, and this is 10 minus 8 left 2/8. Simplify this fraction, you get 3 1/4. Okay, the question doesn't end here. The question says express your answer as a decimal. So I'm going to convert this as a decimal. So to convert this as a decimal, the most common way to do it is to change the denominator of the fraction into either 10, 100, or 1,000, whichever is easiest, go for it. So 4, you can't convert it into tens. But you can convert this into 100 easily by multiplying 25. So multiply 25 to 4, you get 100. Multiply 25 to 1, you get 25/100. There you can see that the decimals value will be 3.25. 3.25 square meter. Now let's look at question number 2. So question number 2, given that the base of the triangle ABC is side AB, so the base of this triangle is AB. So this is the base of the triangle. Identify the height. The height will be AC, okay? So the height has to be perpendicular to the base. So this is perpendicular. Okay, all these are square grids. So if it's square grids, any diagonals will be 45. Diagonal 45. 45, 45, this will be 90 degrees. So AC is the height of the triangle. Now, next question. The figure below is a rectangle. Which 3 points A, B, C, D, E, and F would form another triangle with the same area as triangle CDE? So this is CDE. To have another triangle of the same area, that triangle must have the same base and the same height. All right? So obviously the same base will stick to C and D. Then the question is, what's the height? The height will be, the other point will be F. So with F, the height will be this. And this height are the same. The height of CDE is this line. The height of CDF is this line, and it is common height. And the common base is CD. So therefore, these 2 triangles, CDF, has the same area as CDE. So the answer is CDF. Let's go to question number 4. A rope was cut into 2 pieces in the ratio of 3:10. The shorter piece was 6 meters long. John and Peter shared the longer piece in the ratio of 2:3. What was the length of the rope that John received? So the rope was cut into 2 pieces. So one rope cut into 2 pieces. So one piece is short and the other piece is long, 3:10. Now, the second statement says the shorter piece is 6 meters. So this shorter piece, 6 meters, is referring to this, which means that 3 units is 6 meters. But let's continue. John and Peter shared the longer piece. So this longer piece, 10 units, is shared between John and Peter in the ratio of 2:3. So this 2:3 is to share this. Now let's compare these two ratios. Knowing that this is a sharing of this, meaning that whatever John plus Peter must be equal to this value here. So this is the common base. If they are the common base, then the value has to be equal. So let's make it equal. Make it to 10, multiply by 2 across. So the common base is done. The only value in the question is 6 meters. And this 6 meters refers to the shorter piece, 3 units, which I mentioned earlier. So 3 units is 6 meters, 1 unit is equal to 2 meters. Now, once you get 1 unit, read the question again. What was the length of the rope that John received? So we are talking about this. Do not use this row anymore, use this. Okay? Because this is not relevant anymore after you make common base. So use the ratio that has the common base. So 4 times 2, and that's the answer. Let's look at question number 5. In a bag, there were some black and white stickers in the ratio of 4:7. After 42 white stickers were removed from the bag, the ratio of the number of black stickers to the number of white stickers becomes 16:7. Find the total number of white stickers in the bag at first. So we got black and white starting 4:7. Okay, the black is 4 units, the white is 7 units. Now you are going to remove 42 white. So I draw a line to represent the change, white and minus 42. And after this, before this change, after the ratio becomes 16:7. Now compare the two ratios, the before and after. Ask yourself this question: what didn't change? To know what didn't change is to look at the change in the center here. And look at it, the only thing that changed is white. So therefore, the black didn't change. Nothing happened to the black. So because the black didn't change, the value of black here and the value of black here has to be equal. So let's make it equal. So make it to 16. Multiply by 4. 7 multiplied by 4, 28. So we got the common base done. After you get the common base, the next step you do is look for a value in the question. The value in the question is 42. And that relates to the white stickers removed. So we look at this value of 42 removed. We must ask ourselves the question, this value is represented by how many units? Focus on the white. Before, white is 28 units. After the change, white is 7 units. So the change from 28 to 7, a reduction of 21 units, is equal to 42 white stickers. So 1 unit is equal to 2 stickers. Now, read the question again. Find the total number of white stickers in the bag at first. Take note, the question is asking number of white stickers at first. So make sure you pick the right number. This is white stickers at first. Okay, at first. This is after. So at first 28 units, so 28 multiplied by 2. 56. Okay, now let's look at question number 6. The table below shows the price of roses on normal day and on Valentine's Day. So the table shows on a normal day, per stalk of rose is 120. Per stalk of rose on Valentine's Day is 250. So Yenny bought roses on a normal day and on Valentine's Day. How much more does Yenny need to pay for 1 dozen stalks of roses on Valentine's Day than on a normal day? So this question is very direct. It's asking you for the difference in amount. Yenny pay for 1 dozen means 12. 12 roses on a normal day compared to 12 roses on a Valentine's Day. So let's see the difference between between the price on Valentine's Day and normal day is $1.60. That's for one rose, one stalk of rose. And Yenny buying 12. So times 12. So that is the total difference Yenny pay for 1 dozen stalks of roses on Valentine's Day and on a normal day. Question 6b. Yenny has $50 and she decided to spend it all on roses. What is the maximum number of stalks of roses that she can buy on a normal day? So this question is about normal day. So ignore this information about Valentine's Day. Just focus on normal day, which is this. So with $50, what is the maximum? So easy, you use $50 divided by 120. And then your calculator will show some decimal points. And the decimals are the remainder. But don't just plonk the whatever decimal as a remainder. You need to calculate. So the remainder is 80 cents. How to get 80 cents? Very simple. 41 multiplied by 120. With the answer, find difference with $50. And that will be 80 cents. Okay. More important is this value, 41. That is the maximum number of roses that Yenny can buy on a normal day with $50. Let's look at question number 7. One file and one notebook cost $10. One file and one pen cost $6. Each notebook costs twice as much as a pen. How much does one file cost? Okay, if we look at this statement, I want to highlight to you about this one. Each notebook costs twice as much as a pen. This statement basically tells you the price of a notebook is 3 units. The price of a pen is 1 unit. Okay, I'll come back to that later. But let's create the number statement for the first sentence. One file, one notebook costs $10. One file, one notebook, $10. One file, one pen costs $6. Okay, this statement basically telling you the price of a notebook versus a pen. So price of a notebook is 3 units, price of a pen is 1 unit. It's just like, you think like a price of notebook is $3, but the currency is now in units. The price of pen is 1 unit, okay? So what the question is, how much does one file cost? So what you do is you change this 1 unit, or so one notebook to 3 units, and one pen to 1 unit, because that is the price of the notebook and the pen, right? So when you subtract the bigger number, which is 10 against 6, 10 minus 6, you also subtract 3 units minus 1 unit. 3 units refers to the notebook, 1 unit refers to the pen. Then you subtract one file, with one file you get nothing. So on the left side, after you do a subtraction of the first statement against the second statement, you will get 3 units minus 1 unit, 3 units for notebook minus 1 unit for the pen, you get 2 units. Okay, you get 3 units of the notebook minus 1 unit, pen, you get 2 units. 10 minus 6, you get 4. So 1 unit is equal to 2. How much does one file cost? One file is 3 units. Refer to this, 3 times 2. Oh, sorry, yeah. How much does one file? No, sorry. This is notebook. I see only one file means you have to pick any of these statements. I have picked this statement. In the solution, they have picked this statement. One file is 6 minus 1 unit. Okay, and we have found here that 1 unit is equal to 2. So one file is 6 minus 1 unit, which is 2. 6 minus 2, 4. So the price of a file is $4. Sorry, just now I picked the wrong number. I picked a notebook instead of a file. Okay, never mind. Let's continue with question number 8. Yenny has twice as many erasers as John. So I'm going to record this as a ratio later. Amber has twice as many erasers as Yenny. I know some of you are going to do model, but now that you already learned ratios, you can totally avoid recording this as a model, right? You can record this as a ratio. Amber has 40 erasers more than John. How many erasers do the 3 children have all together? So let's record the first statement. Yenny has twice as many erasers as John. So Yenny to John, 2:1. Amber has twice as many erasers as Yenny. So Amber, twice as much as Yenny. Altogether, Amber has 40 erasers more than John. So before we go further, we need to look for a common base between 2 ratios here. The common base is Yenny, because Yenny is the common identity in these 2 ratios. Yenny over here, Yenny over here. And since they are both the same person, the value has to be the same. So make it the same. Right? Times 2. Now, next look for a value in the question, which is 40, which is the difference between Amber and John. So Amber is 6 units, John is 1 unit. So difference is 5 units. So therefore, 5 units must be equal to 40. 1 unit is equal to 40 divided by 5, 8. After you got the value of 1 unit, you read the question again. How many erasers do the 3 children have all together? The 3 children is made up of 2 units Yenny, 1 unit John, 6 units Amber. Do not pick this, do not pick this row of values because you already make a common base. So use the common base ratio. So it's 2 plus 1 plus 6, not 3. 2 plus 1 plus 6. You get 9. So 9 times 8, and that's the answer. Let's look at question number 9. John and Peter had 50 and 90 cards respectively, meaning John had 50, Peter had 90 cards. After each of them gave away equal number of cards, Peter had thrice as many cards as John. How many cards did they give away all together? So when you read this question, you'll notice this keyword here. They gave away an equal number of cards. When 2 persons gave away an equal number of cards, or sometimes they receive an equal number of items, or when equal number of items are given away or received, the concept here is difference doesn't change before and after. So difference before between the 2 persons is the same as the difference between the 2 persons in the end after. So the difference between John and Peter after the change, which is we do not know what is it, so we put a question mark, will stay the same. So in the end, John to Peter is 1:3. Peter has twice, right? So let's look at the difference. The difference at first is 90 minus 50. 40. The difference in the end is 3 units minus 1 unit, which is 2 units. Since difference remain unchanged, 2 units must be equal to 40, because 40 is the difference at first, 2 units is the difference in the end. So 2 units is equal to 40, 1 unit is equal to 20. So it is very important that you can identify that the difference remains unchanged. And the key is in this phrase, gave away an equal number of cards. Okay? So 1 unit is 20. Question is, how many cards did they give away all together? Very simple. You need to know what they have all together at first compared to what they have all together in the end. That's one way. All right. Another way is to look at one of them. John had 50 at first, and John in the end has 1 unit, which is 20. So John gave away 30. And we know that they both give away equal number of cards. So altogether, John and Peter will give away 30 each. So total 60. 30 times 2. 60 cards. Now let's look at question number 10. John and Peter had $260. Peter and Yenny had $340. Yenny had 6 times as much money as John. How much money did John have? So John plus Peter is 260. Peter plus Yenny is 340. Yenny had 6 times as much money as John. So I can record this way. Yenny has 6 units. John has 1 unit. All right. Now I'm going to replace Yenny over here with 6 units. John over here with 1 unit. And I'll get this. Okay. Now I'm going to compare these two statements. You can see that if I use 340 subtract 260, and on my left side, I need to use 6 units subtract 1 unit. Peter minus Peter. Peter minus Peter will be gone, nothing. On the left side, it will be left with 6 units minus 1 unit, 5 units. On the right side is 340 minus 260. So 5 units is equal to 80. 1 unit is equal to 16. Read the question again. How much money did John have? So John is 1 unit, and that is equal to 16. So John had $16. Let's look at question number 11. Yenny baked 12 more muffins than cookies. She gave Amber 1/4 of her cookies and half of her muffins. As a result, she had an equal number of cookies and muffins left. How many cookies did Yenny bake? The key is they had an equal number of cookies and muffins left. So this is the key. This is an equivalent proportion concept. The fraction of cookies left is equal to the fraction of muffins left. So it's left. So a common mistake people make is they see equal, they use 1/4 of cookies equal to half the muffins. No. 1/4 is what is given away, is not what is left. So what fractions of Amber's cookies is left? It's 3/4. What fraction of Amber's muffins is left? He gave away half of a muffin, so she's left another half, the other half of the muffins. So since they are both equal, the step to solve an equivalent proportion is to make the numerator equal for these two fractions. So the numerator here is 3. I need to change this to 3. I multiply by 3. Make sure I multiply 3 to the numerator and to the denominator. I will get 3/4 cookies is equal to 3/6, times 3 times 2 times 3 is 6. 3/6 muffins. Now that the numerator is the same, what we are looking at is the denominator, because the denominator represents the total. So to read this, it means that the total number of cookies is 4 units. The total number of muffins is 6 units. The total number of the cookies left is 3 units. The muffins left is 3 units. So this is how I read it. Okay. Now, the question is, how many cookies did Yenny bake? So look at the question. There is only one value, and that is 12. 12 represents the total difference in the number of muffins and cookies baked by Yenny. So we are looking at the total difference, which is 6 minus 4. So 2 units is the total difference in the muffins and cookies baked by Yenny. So 2 units must be equal to 12. 1 unit is equal to 6. Now read the question again. How many cookies did Yenny bake? So Yenny baked 4 units, right? This is the total. 6 times 4, 24. Okay, now let's look at question number 12. A group of boys were making cards for Christmas. Half the boys made 3 cards, 1/3 of the boys made 2 cards, and the rest of the boys made 1 card each. A total of 448 cards were made by the boys. How many boys were there? So you see, this is a quantity value question. The quantity here is referring to the boys, number of boys. The value refers to the cuts. So let's draw the quantity value table. So you have quantity, value, total value, okay? So we have 3 columns here because there are 3 groups of boys. The boys that make 3 cuts each, and the boys that make 2 cuts each, and the boys that make 1 cut each. For boys who make 3 cuts, half of them, 2 cuts is 1/3, and the rest make 1 cut. The rest is what? 1 whole minus half and minus 1/3. So let's make this to compare, let's make denominator the same. Let's make it to 6. Okay. So 1 cut each will be 1 whole minus 3, 6 minus 2, 6. So 1 cut each is 1/6 of the boys. So by looking at this fractions, we can look at it as if there are 6 groups of boys, 3 groups is making 3 cuts, 2 groups is making 2 cuts, and 1 group making 1 cut each. Value will be the number of cuts. Then we multiply. 3 times 3, 2 times 2, 1 times 1. So what does this table tell you? This table tells you 1 group. So this table tells you 1 group, meaning you can imagine that the boys and the cuts are organized in groups like this. In every group, there'll be 3 boys that make 3 cuts each, and there'll be 2 boys that make 2 cuts each, and there's 1 boy that make 1 cut each. So in 1 group, they'll be producing 9 plus 4 plus 1 cuts, 14 cuts. So there are many groups of boys organized in this way. Okay, so this is what this table is about. It's 1 group of boys. Bear in mind, there's many groups of boys. And all these numerous groups of boys will make cuts that will total add up to 448 cuts. A total of 448 cuts were made by the boys. So these 448 cuts are made by many groups of boys like this. Every group of boys every group can make how many cuts? 9 plus 4 plus 1, 14 cuts. And in total, there are 448 cuts made. How many groups are there? So easy, 448 divided by 14. 32 groups. So there are 32 groups of boys like this, making cuts. Question is, how many boys were there? If there are 32 groups, let's count the number of boys in each group. In 1 group, you are looking at 3 plus 2 plus 1, 6 boys. And there are 32 groups, so altogether, 32 multiplied by 6, 192 boys. So that's all for the additional practice week 2020. I'll see you next week. Thank you.